Awesome. Some good energy for the last day. Cool. So I'm Jim Bennett. I'm a Microsoft MVP for Foundry and dev tools and stuff like that. And I'm here to tell you about your agents. So, quick question. Well, first of all, who's heard of AI? Yeah, OK, fair enough. But who is actually building agents? OK, seen a few hands. Who actually knows what your agent is doing under the hood? Few hands, OK. Who knows that their agent is actually working? Few hands. OK, this is what we're going to talk about today, about the fact that you probably don't know what your agent is actually doing under the hood. So let's get away from slides. We don't care about slides. Let's see something in action. Now, here I have an agent. Now, all the cool kids tell me that agents are lit. LLMs, instructions, tools. And that's literally what makes an agent. So I have an agent up here. This code here, this 11 lines of code, this is my agent. That's all I have. I'm defining my LLM. I am using an OpenAI model. This is running on Microsoft Foundry. If you haven't heard of Foundry, it's basically a place to run your models, do cool stuff like that. I have my instructions. This particular example, I have been building a procurement system evaluator. So kind of fairly boring line of business application that you're likely to build. People want to buy stuff. Rather than having humans approve or deny, this is an agent that does that approve or deny cycle. So it's a procurement evaluator. You read purchase requests, gather the relevant policy, vendor budget, blah, blah, blah. Do stuff. OK. And then I have some tools. I have a series of tools. I've got a check policy tool, a tool to look up vendors, budgets, that kind of stuff. Now, this is great. This is me kind of scaffolding my application. But I'm using Agent Framework. And Agent Framework kind of just does the rest for me. Literally, the way that I interact with my agent is this one line of code. I say, agent, run. Here's the inputs. Just go and do your thing. And then I get back an output. And then, fingers crossed, it all works. But I don't really know what's going on. It's very much, this is a black box. Decisions are being made under the hood. So the LLM decides, sorry for the anthropomorphization there, but the LLM decides what tools to call, if it should call a tool, what order to call tools. And then the agent framework takes the results, those tool calls, calls the LLM again, does more things. And all I ever see is just the output coming out. That's it. I don't get that visibility over what's happening under the hood. And I just have to hope it works. I can run this in dev. Fingers crossed, it works. So this is the kind of thing that my agent would do. So I could say, look, I want to put in a purchase request, $3,200 I want to spend on the engineering team for an IDE because we need an updated IDE. This goes in, and the agent comes back and says, OK, this is approved. This is why it's approved. Done. Sweet. Complete black box. Could be right, could be wrong. I just don't know. So how do I discover what it's doing under the hood? Well, who's heard of OpenTelemetry? Heard of OpenTelemetry? Yes, so a few of you. OpenTelemetry is a standard way of seeing what your applications are doing. You will bolt this onto your web app. You see how long the requests take. You see your 500s, your 400s, your 200s. You get visibility over what your application is doing. Wouldn't it be nice if we could take that same principle, that same open standard principle, and apply that to AI applications? And you can. So there is a thing called, where are we? Open Inference. Has anyone heard of Open Inference? OK, one hand. Open Inference is an open standard extension for OpenTelemetry that works with the semantic conventions for AI. So basically, it makes AI work with OpenTelemetry. Now, OpenTelemetry are working on a Gen AI standard. It's in a committee, and we all know what committees are like. So maybe one day they will get the standard going. But until then, Open Inference has been around for a few years, and that is kind of an open standard that folks can use for gathering telemetry data from LLMs. And actually, if you were in the session yesterday from Sarah Bird, you would know that Open Inference is the standard that's being used for the new Assert framework and agent control specification that Microsoft are doing. So if I want to put this kind of telemetry inside my application, it's actually not that complex to do it. OpenTelemetry is a standard. The person over there who said, I've done OpenTelemetry, has probably done this. You just drop in I want to trace things. I put in a couple lines of code to say, I want to trace this. I want to send this to Open Inference. And then I just send this to a backend. And that can then, it exposes visibility of what my application is doing. So what I get out the other side is something like this. So what I've got here, this is an application called Phoenix. It's a free open source backend for telemetry data made by Arise, the folks who invented Open Inference. This is kind of the standard default out-the-box open source way of rendering Open Inference data. And this gives me a complete breakdown of what my agent is doing. So at the top level, I have this process, .run, and it says, this is the TechFlow IDE, $3,200, we need the upgrade, and they have the response, yes, it's compliant, it's whatever. This is really what I see for my agent run, but I have so much more information now. I have this tree diagram that shows me everything the agent is actually doing. So actually, Microsoft Agent Framework kicks off an agent, it then calls an LLM. This LLM, I can see the system prompt, I can see the user prompt, I can see what comes out the other side, requests to do tool calls. I can dig deep into a whole lot more attributes. Where's the fun ones? So I can see things like token counts, in and outs. It's OpenAI, we use Microsoft Agent Framework. And I've kind of got this deep level of telemetry across everything that the Agent Framework is deciding to do. Everything that goes into every single part of the system. This is what goes to the LLM, this is what comes back from the LLM. The LLM wants to call a tool. Sweet. It calls the check policy tool, 3,200 TechFlow, gets back a response, and so on, and so on, and so on. So I can start getting this visibility over everything that my application is doing at a very, very granular level. And this allows me to start understanding my application. I can start doing this at scale. I can do this in dev for 1 or 2 as I'm experimenting. I can do this in production for thousands, millions of rows of data. I get to see all the things. And what's cool as well, because this is standard OpenTelemetry, I can do all the standard tricks that folks do. If I want to strip out PII or customer data, I can drop a new spam processor in to strip it out. Anything I kind of want to do to manipulate the data on the way out, I can do that as well. So suddenly, I know what my system is doing. That answers that first question I asked you. Do you know what your agent is doing? I can see inside that black box. But the next question that comes up is it working? How do we know if something works? How do we know if an AI agent is working? Now, who writes unit tests? I'm not seeing enough hands here. I'm not mad, I'm just disappointed. Come on. Now, when we think about unit testing with deterministic code, we are used to writing tests. We say, with these inputs, I expect this output. That doesn't work with an LLM. With these inputs, I will get a non-deterministic output coming out the other side. So how do I know if my LLM is working? Well, the easiest way to do it is ask a person to have a look. Humans can look at But it turns out that actually humans are not the best at evaluating whether something works or not. AI is actually better than humans at doing this for the simple reason that humans get bored. So who here likes having lunch? Who here is doing work the last 10 minutes before lunch and just wants to get it wrapped up as quick as possible so they can go and have lunch? Yes, humans make mistakes. Humans have biases. It's been shown, like, for example, in the prison system, if your parole review is just before lunch, you've got no chance. After lunch, you're sweet, you're out of there. So there's these kind of biases that happen because humans get bored, humans make mistakes. AI is just as good as a human, still makes mistakes, but doesn't get bored, and we can run AI at scale to test whether or not our code is working. So what I can do is I can actually use an AI to see, is my system working? Classic example here is I have these tools that do things. What if the tool didn't work? What if the policy tool didn't return a policy, returned blank, and my agent, being really helpful, goes, well, there's no policy. It must be fine. Approved. You can all buy $1 million worth of software. Yay, all approved, because there is no policy. How can I test for this? How can I discover this? So actually, what I can do now that I have this visibility over everything that happens inside my system, I can take this data and I can actually throw this at an AI and say, is this good? Does it work? Is it actually doing what it's supposed to do? And this is what we call evals. So evals is the fancy AI word for testing. We should have called it testing because people know what testing is. But we have to call it evals because we're cool and different. So whenever you hear the people talk about evals, it's basically testing for AI. And so what I can do is I can start writing, got a prompt here, I can start writing a prompt to say, look at the information that I have and tell me whether or not my AI is working. So here I've got a prompt. You are auditing an automated procurement evaluator. Each row shows a purchase request. The final recommendation produces blah, blah, blah. Decide whether the recommendation is supported by the tool evidence alone. So we're saying the data that comes back from the tools, is the decision grounded in that data? I then have a rubric here for how we score it: approve, reject, flag for review. And then I have spaces where I can fill in the original purchase request, the evidence, the data that comes back from the tools, what the agent said, why the agent said it, and then the final thing, is the recommendation supported by tools, supported, unsupported, return one word. And I've now built a test. I have taken my non-deterministic output of my AI, put this eval on top of it, and this will now give me a deterministic output of supported or unsupported. This is great. I can start testing things. And the way I can run this is I can literally go to Phoenix, download the telemetry data, pass through it, pull out the tool outputs, throw it into this prompt, throw it at an AI, and say test it. And what comes out, I'm going to flip to a different project in Phoenix so it's easier to see this. What comes out is a score. 0 for it doesn't work, 1 for it does. So if I look at this first one here, for example, let's actually go and open up in a trace. First one here. Right, so this one here, this says it's supported. The evidence shows sufficient budget, the vendor is preferred, the purchase amount is under the auto-approval threshold, done. So this has said the data that comes back from the tools agrees with the decision that was made. Cool. But actually, if I look at all my numbers, pass, 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 fail, 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 fail. So it only works half the time. Half the time, my agent is not actually working. It's not doing something grounded in the data from the tools. So if I have a look at, say, this row here, this says it's unsupported, and it tells me that there's sufficient budget, the policy requires VP approval for this level, and this got rejected, but it shouldn't have been rejected. It should have been flagged for VP review. So the policy says VP has to review this. The agent said rejected. What it should have done is flagged it for review because the policy says somebody should review this. So having this LLM as a judge, I can see exactly what is happening, what's going wrong, what mistakes it's making. And so now I've got this great situation where I know what it's doing, I have my inputs, I have my tests, and I have some results. And when I have inputs and tests, I can start building automated testing around this. I can start saying, right, this doesn't work now. I can extract all this data that I've got, all these inputs, and I can put this in like a data set somewhere, and then I can run these inputs through my agent, score it with my evaluator, see what the score is, and then I can start making fixes to my agent and put it through that same pipeline. The same as those of you who put your hands up to say they do unit testing probably have done. If you do test-driven development, you build your tests up front, and you keep running your code till it all goes green. Same kind of idea. I've got my data, I've got my evaluator, I can just keep tweaking my agent until the numbers come out good on the other side. So the classic example for this is model selection. My application is not good, I might try a new model. Or my application is good, but I want to upgrade my model. I want to try a cheaper model. The model provider's pushed out a new model. How do I make sure my application still works with model changes? And so I've got an example here. This here is exactly the same application, the same agent, nothing has changed, except I'm running this against GPT 5.4 instead of 4.1. Oh, look at all those ones there. This is now 90% effective. I've made no changes to my application. All I've done is change the model that I'm calling. But because I've got this ability to have this data set, have these evaluations, and run this continuous testing loop, I can score this. I can tell when things are working or when things have broken. Now this I can then take a little bit further. So who uses a coding agent? Few hands. Okay, GitHub Copilot? Any Claude people in the room? It's okay, Microsoft won't shoot you. You know, you're fine. Now, so if you've got a coding agents can have skills. Skills can access this data. So I can literally spin up GitHub Copilot CLI or Claude and say, okay, here's my code. Yeah, here's the GitHub repo with my code in it. Here is the inputs that I run to my agent. Here are the evaluations that I run. I want you to fix my application. And so the coding agent can take all this data. It can spin up my application in a sandboxed environment. It can pump my inputs in. It can run my evaluations. It can look at the results. And then it can go back and tweak the prompt, change the model, adjust the tool descriptions, whatever it needs to do, and then run it again. And then run it again. And slowly it can converge on a much better solution. Yeah, in this case, I went from 50% to 90% just by me changing the model. That's very much a contrived case. In a lot of situations, you need to iterate on the prompt, you need to iterate on tool descriptions, try different models, whatever you want to do, and eventually you'll find over like 4, 5, 6 cycles, your coding agent will kind of converge on a point where you're kind of hitting that 90% effective rate for your agents. Top tip, agents will never be 100%. Humans are never 100%, agents will never be 100%, but you want to kind of work towards this 90%. And so suddenly, I've got everything I need to build that self-improving software loop. Anyone here does self-improving software? Anyone here use the agents to fix? Got a hand over there? Yes, that's a couple of hands. This is kind of the future. We have the ability to monitor applications. We can see what's going wrong. We can ask our coding agents to fix that. This is kind of the future of the software that we're building. So that is... Skip for those. We didn't do slides. We just did some. So what have we talked about today? When you have an agent, it's a black box. You do not know what it's doing. You need to add observability so you can see what it's doing. There's industry standards for this. Open Inference is the industry standard for doing this. This gives you the view on what you're doing. Then once you've got this, you can start building evals. You're using an LLM as a judge to test your agent runs, see what it's doing. And then you can use this data to drive that self-improving software loop. You deploy your models to Foundry, you build a Microsoft Agent Framework application, you can GitHub Copilot CLI, you can say, fix it, goes off, fixes it, jobs are good. And there we go. That is how you can use evals to understand your application. So I'm Jim Bennett, so Microsoft MVP. If you've got any questions about this, scan that. That's got all links to all my LinkedIn. And so if you want to hit me up with any questions after this, more than happy to geek out on things.
Amazing.
And then once you scan that one, if you want to get started with Phoenix, it's free, open source. It's just a bit off the screen. It's free and open source, so scan that QR code and you can grab Phoenix. You can run it completely locally. You can. I would have showed it to you deployed to a container app, but my Microsoft MVP Azure credit ran out 3 hours ago. So literally, I have no Azure credits to show off on Azure, but that's how you can get started on there. And then finally, if you want the code for this, up here in this GitHub repo is all the code so you can reproduce everything that happened today. And if you've got any questions, come find me afterwards. Happy to answer your questions. Thank you.